All right, so organic molecules, they can be mixed, but when we characterize things, we want them to be pure. So how can we purify things? We use a molecule's physical properties to purify it. So we could physical properties could be boiling point, could be solubility, and its chemical properties can also be harnessed there too. So um, if we want to isolate a carboxylic acid from a mixture of molecules, we can change the molecule chemically, and that will impact its physical properties. So what does that mean? Well, ions are aqueous soluble, and neutral molecules generally are organic soluble, so they'd be in an organic solvent. So if we had a mixture of these two things, much like we have on the bottom of page 6, as they look right here, they'd be both soluble in organic solvents. So we can't really separate them very easily that way. But they do have differing acidities, right? We've gone over that pretty extensively at this point. This is a carboxylic acid. It's a lot more acidic than an alcohol. So the base that we often use to deprotonate a carboxylic acid is bicarbonate, is what we call it. It looks like this. So it has, this is bicarbonate. Usually we have sodium bicarbonate. Those that are in lab have used this a ton. So sodium bicarbonate. So this is a base. It can deprotonate acidic protons. The most acidic proton in this molecule is this OH here, that's part of the carboxylic acid. If we add it to an alcohol, the most acidic proton here is that one as well. So what we have to figure out is, well, what side of the equilibrium would be favored once we were to deprotonate these acids. So we deprotonate the benzoic acid. That produces the carboxylate plus carbonic acid. We deprotonate the alcohol. We have the alkoxide, the O minus, plus carbonic acid. So what do we not know here? We don't know the pK of carbonic acid. That's not been one that we've talked about. It turns out that the pK of carbonic acid is 6.4, whereas the pK of a carboxylic acid, we know this one is around 5, and the pK of an alcohol is around 16. So while if we mix these two, this is a strong enough base to deprotonate the carboxylic acid, forming the weaker acid over here. So the equilibrium on this side is going to move over here. And if we take that mixture, we're going to deprotonate the carboxylic acid. But since this is not very acidic, the equilibrium of this reaction is going to be on this side. And I separate these two things out into two different equations, but it's really important to understand that this isn't happening separately. These are in the same solution at the same time. But when both of these have the opportunity to react with the bicarbonate that's just floating around, this is going to react with it, forming that ionic species. So now we have ionic carboxylate, which if it's ionic, what does that mean? That means it's going to be aqueous soluble. So this is going to be now in the aqueous layer. Versus when these things are mixed all together, this is on this side, this is still neutral, which means it's organic soluble. So that would effectively separate these two things out. We would use a separatory funnel to do this. We shake it, the layers separate, and this would be in the aqueous layer, this would be in the organic layer, and that would allow us to separate those two molecules from one another. That's what we talk about even more on this next page, page 7. And there's another video to talk about that. But I just kind of wanted to put this up to the video at this point. So this is what a separatory funnel looks like right there. We have a organic layer that's CH2Cl2, that's dichloromethane. And we have, after we add some aqueous solution, we have two layers. The water's on top, the dichloromethane's on the bottom. That deprotonated carboxylic acid is in the water layer. The alcohol is in it's deprotonated, so it's neutral. Or sorry, it's still protonated, so it is neutral, and that leaves it in the organic layer. So then we're able to just drain out the layers independently, and we have this in our water layer and this in our organic layer. So that's how an extraction works, and we'll be talking more about that very soon. So thanks, Jeff.